Okay, now we're ready to start doing some equations here. The reason why I turned on the displays for the dimensions and then the dimension names is so that A, I can interpret what they are, and B, I can pick them off the screen. This is a really handy feature for equations, okay? So I did it so I could pick them, and you'll see here in just a second what that means. So you need to insert equations. So it's either insert or, let's see here, it's tools and then equations. There we go. Tools and equations. And it pops up this screen. And what we're going to do is we're going to dynamically make these. And per the instructions, the first one you want to make is the number of flanges. Okay? So we want to add an equation. And what does it relate to? What does it relate to? The number of flanges relates to the number of instances. So I'll click number. Right now it's blank because I didn't have one pre-selected, but I'm going to go ahead and pick this, and you'll see it'll put the name up here. And this is the dependent variable. The way the equations work are whatever's on the left side is dependent on the right side. So the number of instances depends on or equals to then what? Well, it tells you the outside diameter divided by 1.3. So we've got to find outside diameter, which I see is right here. And I click it, and it puts outside diameter, and I simply continue with divided by 1.3 and OK that equation. And of course it equated to 4, and I have 4 flanges. All right, so no shock there, but it's repeating what I'm expecting. The next equation is the angle for each of these rotations, okay, or the angle for each of these instances. So again, we want to add an equation. And then what's dependent? It's the angle, so it's this one, circular pattern, 90 degrees equals what? Well, based on a full 360 degrees, it would be the number of, it would be 360 divided by the number of flanges. So 360 divided by, and then what? Well, it's not a constant, it changes. So again, it's the number of instances. So the first equation would solve the number of instances. The second equation here dictates the angle of each of those instances. Okay, so we'll OK that one. And of course, there are 4 instances, and 4 into 360, or 360 divided by 4 is going to give you 90, so that all makes sense. The next item here, the thickness, okay, 3/8. We already solved that and contained it, or constrained it using the sketch. And then the center hole, we did that also in a sketch. Okay, so I'm going to move along here. We're going to get to a little further down. Then there's a hole with that same, we did that one with a sketch also, we're good. So each hole is always centered in the flange. Okay, got it. Adjacent 2 sides of the flanges are always parallel. Yep, that's what I made my sketch and shot it straight out. So that's all captured. I do believe that's, oh, there are a few other things. Oh, wait. If I OK that, nothing's going to change because I'm using the current variables. But you see it puts a little sigma on there? That means it's the equation, and those are driven by equation. That's my little reminder to save. One of the things I want to point out to you is that not only do we have to know the angle of the rotations for each of the instances, but remember this one right here? This one right here, this one relates to that hole. And the hole is always half of what the angle rotation is. Currently it's 90, so 45 works. But this is part of an equation, so if this goes to say 100, then this should be 50. But this isn't controlled by anything. So I need to add this into my formula. I need to add this to my equation. So I'm going to right mouse click, edit equations. I want to add an equation. This variable is dependent on or equal to this variable divided in half. That's the relationship. And of course, it's, 45 degrees. So that's good. I do believe we should try this. I'm going to change this to 6 and rebuild it. Oh, look at that. Okay, well, some of the things that did work is the diameter got bigger for sure. It went to 5 instances because if you take the diameter divided by 1.3, you get a fraction of a whole number, and it ends up being 5 point something, and they rounded it to 5, no problem. But you see how the angle here, the 45-degree angle for the hole, doesn't match up with the 90-degree angle of rotation for the instances. So this is an issue with the construction of it. So I'm going to back up one and show you what I mean. You see this hole got a 45 degree based on the 90? Well, that's true, but what you see is that this one references the horizontal and this one references the vertical, so they're not coming from the same location. So what I'm going to do is I'm going to edit this sketch and move this dimension, this angle dimension, over to this side and see what it does. Okay, so just a moment.